Hi, this is Andrea Hendricks, and I want to talk to you about solving rational equations. A rational equation is basically an equation containing fractions. We saw these back in Chapter 2 when we were dealing with linear equations. Here we will also encounter equations in which the fraction has a variable in the denominator. And so whenever we have a variable in the denominator, we have to be careful that the values that we have as our solutions are not restricted. In other words, the values that we have in our solutions cannot make the denominator 0. So that's really one extra step that you have to do in this process. So let's just practice that skill for a moment. What values must be rejected from the solution set of the equation 3 over x plus 2 minus 5 over x is equal to 1? Well, to find that out, we have to find out what values of x make the denominator 0. So we could set each denominator equal to 0 and solve. So we would get that either negative 2 would make the first denominator 0, or the value of 0 makes the second denominator 0. So 2 and 0 would have to be rejected from the solution set. Now the steps to solve a rational equation should be somewhat familiar to you. We're going to first find the least common denominator. Then we're going to multiply both sides of the equation by the least common denominator. Then we'll solve the resulting equation. That equation might be either linear or quadratic. If it's quadratic, we have to solve it by factoring, by setting it to 0, and so forth. And then we're going to reject any solutions that make the denominator 0. So let's go through some examples of that. Here's my first equation. 4 over y plus 1 over y is equal to 2. So we know that the least common denominator is just y, since that's our only denominator. Then we're going to multiply both sides of the equation by 4 over y. Multiply both sides of the equation by y. And then we will distribute on the left. So that actually becomes 4 times 4 over y plus y times 1 over y is equal to y times 2, which is 2y. So on the left, we get just 4 plus 1 is equal to 2y. 5 is equal to 2y. So therefore we get, dividing by 2, that y is equal to 5 halves. Now notice that 5 halves does not make our denominator 0. The only value to reject would have been 0 itself. So 5 halves is acceptable in the solution set. Now you could of course plug that value in to see that you get a true statement. Another example, r minus 5 over 2 is equal to r plus 2 over 3. The least common denominator there is 6. So you can multiply both sides by 6. This might look familiar to you when we talked about ratios and proportions, where you could cross multiply as well. But it's the same result. If we multiply the left by 6 and the right by 6, 2 goes into 6 3 times. So now we multiply 3 times r minus 5 to get 3r minus 15. 3 goes into 6 2 times. So 2 times r plus 2 is 2r plus 4. So then we could subtract the 2r to get the variables on one side, to get r minus 15 is equal to 4, and then add 15 to both sides. So r is equal to 19. Since neither one of our denominators had a variable in it, there are no restrictions from the solution set. So the solution set is consisting of the value 19. K over k minus 4 minus 5 is equal to 4 over k minus 4. So here, the least common denominator, again, is just what's in the denominator, which is k minus 4. So if we distribute this k minus 4 to each term of the equation, we will get a new equation without fractions. But it is equivalent. So in multiplying through by this, we will eliminate the k minus 4 from the first term to get just k. Now be careful here, we have a minus 5 times k minus 4, so we're going to distribute to get minus 5k plus 20, and that's equal to 4. Combine like terms on the left to get k minus 5k is negative 4k plus 20 is equal to 4. Subtract 20 from both sides. So we get negative 4k is equal to 4 minus 20, which is negative 16. So divide by negative 4 to get that k is equal to 4. But you can't be too quick through these problems, right? What happens with k equals 4? K equals 4 makes our denominator 0, so we have to reject that solution, and therefore our solution set is the empty set. The reason this happens is that we get an equivalent equation, but not one that's exactly the same type. So anytime you change the form from rational to linear, you have to make sure that the solutions that you get work in the original problem. The k equals 4 would solve this linear equation, but it makes the first equation, the original equation, undefined. Another example, 2 over t squared minus 4 is equal to 3 over t squared minus 2t. This one's going to require a little bit more work to find the LCD. We need to rewrite this so that each denominator is in factored form. T squared minus 4 is the difference of t squared, so it's t minus 2 times 2t plus 2. That's equal to 3 over t squared minus 2t has a t in common, and that leaves a t minus 2. So our LCD has to consist of all the different factors. So from the first denominator, it has a product of t minus 2 times t plus 2. Our second denominator requires a factor of t and t minus 2. We already have the t minus 2, so we need a factor of t. So we're going to multiply through by t times t minus 2 times t plus 2. I can fit it all in here. Okay, so now eliminating the common factors, the t minus 2 times t plus 2 is eliminated, so we have a t times 2, which is 2t. That's equal to the factors of t and t minus 2 are eliminated, so we have t plus 2 times 3, which is 3t plus 6. So we can subtract 3t from both sides to get 2t minus 3t is negative t is equal to 6. Dividing by negative 1 gives us t is equal to negative 6. Now understand that the only things that make our denominator 0 would be a positive 2, a negative 2, and a 0. So since negative 6 is none of those numbers, that is our solution set. Let's look at one last example. 3 over r plus 3 minus 2 over r minus 3 is equal to negative 12 over r squared minus 9. Well, r squared minus 9 factors as r plus 3 times r minus 3, so that happens to be our least common denominator. So if we multiply every term in the equation by that, let me get a minute here to write this all out. Okay, I'm going to squeeze this LCD in right here and then cancel what's common. So we have r plus 3 cancels, so 3 times r minus 3 is 3r minus 9. The r minus 3 is a common factor, and again, be careful with this minus in front of the 2. We have to distribute the negative 2 to get a negative 2r minus 6, and that would be equal to just negative 12. And so combining like terms, 3r minus 2r is r, negative 9 minus 6 is negative 15. That's equal to negative 12. So we can add 15 to both sides. So we get r is equal to 3. But what's special about that 3, it makes the second denominator and the third denominator 0. So we have to reject that. Therefore, our solution is the empty set. Okay? So if you have any questions about this, please contact me. Thank you.